So 12.4, let's start to find the unit tangent vector, which is t of t is equal the derivative of r of t over the length or the magnitude of r prime of t. So the first example, they're telling you find the unit tangent vector to the curve, this one. So here's the curve, which is r of t equal t cubed I plus 8t squared j. And there's no k. So it's 2-dimension and t equal 1. So we're going to do exactly the same thing. Let me check if, yeah, there is a red part. That means it's going to change. So the first thing, what I'm going to do, I'm going to write down r of t in the component form. That means t cubed and 8t squared. Then r prime of t is going to be, derivative for this one is going to be the derivative for each part. So it's going to be 3t squared and 16t. Now, it's up to you. You want to plug in the t right away. If you want to wait until you find the tangent vector, then plug in the one. It's up to you. So here, I'm just going to keep going, find the magnitude for the derivative of r of t, which is going to be the square root for the first component. That's meaning 3t squared plus 16t squared. So again, it's up to you. You want to plug in the r of t right away or no? That's mean this one is going to be the square root of, here is 9t squared, t to the power 4, plus, let's see how much the 16 was going to be. 16 times 16, it's going to be 256. T squared. You can keep it like this because we're going to plug in the t here. That's mean the unit tangent vector with respect to the t is going to be r prime to the t over the length of r prime to the t, which is equal, r of t is 3t squared and 16t over 9t to the power 4 plus 256 t squared. Then I'm going, so you can keep it like this. Then I'm going to find t with respect to the 1, because t equal 1, and that's what it asks us to find. Plug in 1 here. So this vector is going to be 3 times 1 squared and 16 times 1 over square root of 9 times 1 to the power 4 plus 256 1 squared. Then the next step, you're just going to simplify this one. So it's going to be 256 plus 9 and take the square root for, it's going to be 256. So the square root of 256 is going to be 16. In fact, not 256 because we had to add the 9. 256, add the 9, 265, the square root of 265. 265. That means we have to simplify it. That means this one is going to be 3, and here is 16 over the square root of 265, which is 265. Let's say divided by We can't by 25, 265, let's say by, you can't by 16, 265, divided by 265. Which number are going to multiply by number to get 265? We have to find the root. And I think it's supposed to be, yeah, square root. I did something wrong. 9 times, this is 9. And this is already, here's, I think here's the wrong, no, it's 16 t, then squared, so 265. 16 times 16, 256. And you're gonna add the 9. Okay, that's right. Because you can't simplify 265, so just keep it like this. This is the unit tangent vector for this curve line or position vector R of t. But if you can simplify it, you have to simplify it. Because if you have different type of t, like t equal 4, you can simplify it. So this is the first question. Next example, you can, because they ask you here, they ask you to find t to the 1. So instead of finding r t to the t, you can plug in right away. 1 here and 1 here. To find just the number which is equal is going to be square root of 265. And they're not asking you to find the tangent unit vector with respect to the t. They ask you to find the tangent unit vector to the 1. That's mean on the top is going to be just the 3 and 16, because I'm going to plug in here. R prime to the 1 is going to be just 3 and 16. And then when I need to find this one, this part is going to be on the top, and the length of r prime to the, with respect to the t is going to be on the bottom. That's mean here. But if they ask you to find the tangent unit vector with respect to the t, you have to do exactly the same steps. Let's go to the next example. We're going to do exactly the same steps. R of t is going to be 7 cosine ti plus 7 sine tj. So let's do the second one, which is going to be R of a t is going to be 7 cosine ti 7 cosine ti plus sine 7 sine ti tj. That means this is the second one. R of t is going to be equal. I'm going to write down in component form. That means 7 cosine t and 7 sine t. 7 cosine t, 7 sine t. Now, next step, we need to find the tangent, the unit tangent vector with t equal pi over 4. So we're going to do exactly the same steps. And again, if you want to plug in the t right away, it's fine. But first of all, I'm going to say r prime with respect to the t is going to be equal. The derivative of cosine is going to be negative sine. So it's going to be negative 7 sine t. And the derivative here is going to be 7 cosine t. Then I need to find the tangent unit tangent vector with respect. So I'm going to plug in now pi over 4 here. So the derivative of pi over 4 is going to be equal -7 sine pi over 4, 7 cosine pi over 4. That means this one is going to be equal -7 over square root of 2 and here is 7 over square root of 2. If you want to rationalize this one, is going to be -7 square root of 2 over 2 and 7 square root of 2 over 2. Sometimes it's easier to work. Go ahead.
The sine of pi over 4, isn't it square root of 2 over 2?
Sine pi over 4. Which one? Talking about this one? Because pi over 4 is what? Is 45, right? So sine
Yes.
pi over 4 is going to be the one this number, and one in the, which is going to be the same thing. 1 divided by square root of 2. Is that the sign? The sine for 45, the cosine.
No, it should be square root of 2 over 2.
Yeah, because we're gonna rationalize. It's square root of 2 over 2.
Oh, okay.
Yeah,
I see.
that's what. Yeah, because I'm rationalized, so square root of 2. But in fact, the sign for the theta pi over 4 is 1 over square root of 2, but I'm always rationalized, so 2 square root of 2 over 2. So the same thing. Okay.
Okay. Yeah, the unit circle has it already done, so I was confused here.
So this is the first. So you see, so we're not gonna go ahead and plug in everything, but by plugging the theta is going to be easier because they ask us to find the unit tangent vector with respect to pi over 4. So the next step, I need to find the length for this one. That's mean the length with respect to the t, which is going to be equal the square root of, is going to be -7 sine t squared plus 7 cosine t squared. So like you can write down like this, simplify it, or you want to plug in the t right away, it's going to be fine. So if you just want to simplify it, -7 and 7 squared is going to be 49. Sine squared, this one is going to be positive. So sine squared is going to be 1. So it's going to be the square root. I'm just talking about this one without plugging the t. The square root of 89. Let's check that. If we plug in pi over 4 is going to be the same thing, square root of 98. Because if you're working on this one, it's going to be the square root of, this is 49 sine squared over t, plus this is also 49 cosine squared over t. Now sine with the cosine is going to be 1. That means it's just going to be the square root of 49 plus 49. Let's do another step. So it's going to be the square root of 49. And here is sine squared over t plus cosine squared over t, which is everything here equal 1. That means it's going to be, sorry, this is a common, yes, the square root of 49, which is equal 7. The same thing. Let's try if you plug in pi over 4 here. That means it's going to be -7 square root this one, square root on this one. I'm going to do it on another paper because we have to get the same result if we plug in or no. So if you plug in from here, -7 sine pi over 4, and everything here is squared, plus 7 cosine pi over 4 squared, and everything here is squared. That means it's going to be this one -7 square root of 2 squared, and plus this one is going to be 7 square root of 2/2 and squared. If you add these together, it's going to be, because this one is going to be 49 2/4, and you're going to add 49 2, I'm squaring every part over 4. Is that going to be the same result? 49 times 2 divided by 4. So, okay, this one plus 24.5, 49. You see, it's going to be the same thing. Because if you just simplify this one, it's going to be 24.5, and you're going to add 24.5 under the root. That means it's going to be square root of 49, which is equal 7. So if you plug in, if you simplify it first, it's going to be the same result. So this is 7. Now the tangent with respect to the 1, not t, not 1, it's pi over 4. The unit tangent vector with respect to the pi over 4 is going to be r prime of pi over 4 divided by the length of r prime to the pi over 4, which is equal this vector -7 square root of 2/2 and 7 square root of 2/2 and everything divided by 7. This one divided by this one, you're going to cancel the 7, so it's going to be negative square root of 2 divided by 2, and here is going to be square root of 2 divided by 2. You can write down this. Give the second one. Yes. So that's what we got. Let's check that. So vectors, check. And we're just gonna type this one, negative square root of 2 divided by 2, and comma, another fraction is going to be square root of 2 divided by 2. Square root, yes. Here we go. This is the second one. Let's check the third one. Yeah, the third one is important. I think number 4, you're gonna get exactly the same thing. Find the tangent unit vector t, and we have, this is the third one. We have r of t equal 5 cosine t and 5 sine t with the 6. 5 cosine t here's this with the I. No, didn't say with the I. They already give us with the component form. And 5 sine t with the 6. So that's the same example, 5, 5, okay. And the point, they give you a point P, which is equal 5 over square root of 2 and 5 over square root of 2 and 6. In fact, maybe you're gonna get exactly the same one. So I'm trying to solve it for you. Let's check now. So the first step, we're just gonna need to find the tangent unit, the unit tangent vector. So exactly the same steps with respect t. They already give you t equal pi over 4. Because you see, tangent vector to pi over 4. That means the first step we're gonna find r prime of t, which is equal r prime of t is going to be negative 5 sine t and 5 cosine of t with the 0. So this is the prime. You can find right away how much is going to be r prime with respect to the pi over 4 by plugging this one. So r prime pi over 4 is going to be negative 5 sine pi over 4 and 5 cosine pi over 4 with the 0. So it's going to be negative 5 square root of 2 divided by 2. R prime, yeah, negative 5 square root of 2 divided by 2 and 5 square root of 2 divided by 2 and 0. So I'm going to put second on this one because I'm going to use it. This is r prime pi over 4. This is the first one. Now we're going to keep going. We need to find the unit tangent vector. That means I need to find the length for r prime, which is this one, the length for this one. That means the length of r prime of t is going to be square root of the first component squared. That means negative 5 sine t squared plus 5 cosine t squared plus 0 squared. You can keep it like this because next step, you don't have to simplify it because you're going to find the length of the derivative with respect to the pi over 4. That means I'm going to plug in a pi over 4 right away here. Or if you want to simplify it, this one is going to be 25 sine squared. This is a 25 sine squared to the t plus also 25 cosine squared with the t. This is 0. Then simplify it more. I'm going to take the 25 as a factor out the 25. And it's going to be sine squared of t plus cosine squared of t. This one equal 1. That means it's going to be square root of 25 and equal 5. If you want to plug in the pi over 4, you're going to get exactly the same thing. So now the tangent, the unit tangent vector with pi over 4 is going to be the derivative of r pi over 4 divided by the length of the derivative with respect to the t which is going to be, here's the derivative. That's mean negative 5 square root of 2 over 2 and 5 square root of 2 over 2 and 0, and everything is divided by 5. Then it's going to be 5 by 5 is going to be negative square root of 2, negative square root of 2 divided by 2, and square root of 2 divided by 2 with this 0. So we're done from this part. This is only just the first part. Now the second part, we need to find the parameter set of parametric equation, which is equal, plug in the pi over 4 here. So it's going to be 5 square root of 2 over 2 and negative 5. Plug in is going to be 5. I'm not taking the derivative over 2 and 6. So the derivative for this vector which is we already have with respect to the pi over 4, have to write down pi over 4 here. It's going to be, here is the new vector, which is negative 5 square root of 2 over 2 and 5 square root over 2 with the 0. This one is going to be r of a t, r prime over t, which is the angle here is 90. That means this one is going to be normal, which is perpendicular to the position vector. So this one is going to be A, B, and C. That's mean you're going to use the point, which is the terminal point for this position vector. This is P, which is the point 5 square root of 2 and 5 square root of 2 with the 6. And the terminal point here. So the tangential vector, which is the r prime for t, is going to be perpendicular to this one. That's mean this is t. So this one is going to be A, this one B, and this one is going to be C. Now I can use the point with A, B, C to find the parametric equation. So that's mean X is going to be, we'll keep going here. X is going to be X1 plus AT. That's mean X is going to be X1, which is 5 over 2, 5 over square root of 2, plus, that's mean minus 5 square root of 2, no, square root. We can rationalize this one too. Yeah, I'm gonna rationalize, not now. Over 2t. That's mean X is going to be rationalize this part, 5 square root of 2 over 2 minus 5 square root of 2 over 2 with respect to the t. That's mean X is going to be, take 5 square root of 2 divided by 2 as a common, factor this one out, so it's going to be 1 minus t. This is only for the X. We're going to do the same thing for the Y. So for the Y, it's going to be Y1 plus AT, BT, which is going to be Y equal Y1 is the second point, 5 over square root of 2 plus b5 square root of 2 divided by 2, and here is t. Y is going to be rationalized, this part, square root of 2 divided by 2 is going to be plus square root of 2 divided by 2 with the t. That means y is going to be 5 square root of 2 divided by 2. Let's factor out this. So it's going to be 1 plus t. For the z, we have 0 here. So z equal z1 plus ct. So it's going to be z equal z1 is 6 plus c, which is 0, t, that's mean z equals 6, which is only like the height. So we have 3 parametric equations. How we can write down this? Separate list, use t with a comma. So okay, we're gonna separate the list with the comma. And okay, so it's going to be x equal. The first thing, this one equal. How much we got this one? We got negative. So click on the vectors and go back here. It's negative square root of 2 divided by 2, comma, and square root of 2 divided by 2, and the last one is 0, comma with 0. And here, let's check this one. I hope there's nothing wrong. X is equal 5 over square root of, let's do this one, 5 square root of 2 divided by 2, and parentheses 1 minus t, and here's comma, y is going to be equal, here is the y, the same thing. I can't do copy paste, so I have to write down this again. So 5 square root of 2, 5 square root of 2 divided by 2, and now we're gonna put parentheses, but 1 plus t, and the last one, which is comma, c equal just 6. Let's check that. Here we go. You got it. So number 4, you see there is no red part. You're gonna do exactly the same thing with number 4. Let's see. Yes, let's check it. Let's check number 4. Example 4, find the principal unit normal vector, which is the formula is the principal unit with respect to the t is going to be the derivative of the tangent vector over the length of the derivative of the tangent vector. The same thing here with this one, they ask you to find, here's with t equal 2. So example 4 is going to be, I have r over t equal ti plus 6 over tj, ti plus 6 over tj, and t equal 2. So what we're going to do here, if you want to solve this one, first of all, I'm going to write down the component form, which is equal t, and I'm going to write down this 6t to the negative 1, because this one is easier to find the derivative, and t is exactly the same thing. So now next step, we're going to find is like, I know it's a lot of steps. So the first thing we're going to find the derivative of r of t is going to be 1 and -6 t with -2. That's mean -6 over t squared. Then find from this one, I'm gonna find r prime with the 2, plug in the 2 right away. That means it's going to be -6 over 4, which is -3 over 2. Let's keep it like this. And next one, the length of r prime of t in general is going to be the square root of this one squared plus this one squared. So it's 1 squared plus -6 t -2 squared. That, yeah, just t. Okay, so let's square this one. This is 1, and this one is going to be 36 t to the power 4. So this one is going to be square root of 1 plus 36 t to the -4, which is equal 1 plus 36 over t to the power 4. Make it equal denominator, that's mean t equal 4, t equal 4. So let's do it here. So it's going to be t4 over t4 plus 36 over t to the power 4. That means this one is going to be equal 1 over t squared and t to the power 4 plus 36. I can simplify it more. This is in general. If you want to find with respect to the 2, you're just going to plug in 2 here. The same thing, you're going to plug in 2 here. Now I'm going to use this one, and I can use this one. If I need to find the length with respect to the 2, is going to be 1 over 2 squared square root of 2 to the power 4 plus 36. It's going to be 1 over 4 square root of 16 plus 36, 52. 52, the square root of 52, 7 points. I'll just give it 52. There's just extra steps, this one on this one, but we can check if we can use it. They ask you to find the normal with respect to the 2. So the 52, this one is going to be 1 over 4, and this is 4 times 26. That's mean 4 times 26 is 52, so it's going to be 2 over 4, not 26, times 13. It's going to be 4 times 4, 12, 1, okay. So 2 square root of 13. One over 2 square root of 13. So now this is easier to use. Let's check if we can find the derivative with respect to the 2. That means this one is going to be 1, and -6 divided by 2 squared, because this one is -6 over t squared. That's mean over 4. So it's going to be -3 over 2. That's mean, because they asked us to find it with respect to the t and with t. So everything I'm going to plug in 2 is going to be easier to use. Now the tangent with respect to the 2 is going to be r with respect to the 2 divide the length of r, the derivative with respect to the 2. I have this one, I have this one. I just need to. Now with numbers, we don't have to find it with variables. So it's going to be 1, 3 over 2 and divide by half square root of 13. Oh, let's do it. Square root of 13 over 2. So t with respect to the 2 is going to be, but we can't find that's the problem. Yes, you're right. We found this one, but we're not gonna find the derivative of t with respect to the t because we have to plug in 2. So we can't find the derivative. We have to go back and plug in the normal one. So because we don't need this one, so I'm not gonna use it. Because now I need to find it, the tangent vector with respect to the t. So when I find the derivative, so I can find the principal unit vector. So tangent with respect to the t is going to be this vector, which is r prime with respect to the t, divided by r prime with respect to the t. That's mean the tangent with respect to the t is going to be 1, -6, t -2, divided by the length, which is 1 over t squared, square root of t to the power 4 plus 36. Yes, so I need to find the tangent vector. So because the derivative over the length of the derivative is going to be for the normal vector. So I need to find the tangent vector. So when I derive it, it's going to be, I can find the normal vector, the principal unit normal vector. So this one, just what I'm going to do, I'm gonna raise this one to the half and get it on the top. And this one t squared, if I multiply it here, okay. So this one is the same thing. I just need to simplify it. So if I say t to the power 4 plus 36, this is not a vector. And here is t squared, t -2, which is 1 over t squared. And here is the vector 1 and -6, t -2. Then what I'm going to do, I can distribute this one because it's a number. So the tangent with respect to the t, we're trying to simplify it as much as we can, plus 36 to the 1 over 2, -1 over 2, because this is the radical. And this one is going to be t -2. This is, no, it's already negative. It's going to be negative. When you raise it up, it's going to be positive. This one's going to be squared. So this one's going to be t squared and -6. Now, I'm just going to work with this one. Here is the vector. This is just like a scalar. It's not a vector. Be careful with this one because it's the length. So the derivative of t is going to be derivative for this one, which is derivative for this part, t to the power 4 plus 36 negative 3 over 2 times the derivative of inside, which is 4t cubed. And the derivative for this vector is going to be 2t and 0. Let's see. The derivative yes. And this one, we're missing a t here. T squared. This is negative 2. Together this. When I did the derivative here, is negative 6 times negative 2 is going to be 12. So this one is the 12 t to the negative 3.
Didn't you multiply t squared times that?
Yes, I have to do the derivative first. Then I'm going to multiply the t. You're talking about if I have, yeah, which is also makes sense. We can, that's why I need to check it. So that's what we're gonna do here. The derivative of the first one times the derivative for the second one minus the second one here. The derivative for the first one, negative 1 over half. This one minus 3 over 2, 4t cubed. Minus this 1, that means I can take t to the power 4 plus 36 as a common, as a factor out. The left is going to be t to the power 4 plus 3 from here. T to the 4 plus 36, because this is 1. Now, if you multiply this one times this one, is going to be negative 1 over 2. And we're going to keep this one exactly the same. And from this side, which is 2t and 0, minus this one cancel with this one. So it's going to be negative 2. And we have 2 cubed here times this one is going to be t to the 2 cubed. And we have half here, yes. T squared minus 6. We have t cubed here. We're going to take this one out. 4t cubed. So this is going to be here. Just 2 minus 2 and t 3 with the 2. 5 minus 6t squared. That's what it should left over.
We get it.
So now we have to simplify everything. So t prime over t is going to be t to the power 4 plus 36 negative 3 over 2. Let's simplify this one here. This is a vector. There's no space here, but this is a vector. Write down this before we can simplify it. So now we just need to simplify this one. T to the power 4 with this one is going to be 2 t to the power 5 and plus 36 with this one is going to be 72t. With the 0 is not going to change anything because we're doing this one distribute on this. This is a vector. Okay, so minus everything here with the 0. So I'm going to keep it as a vector with the 0 minus now 2t cubed. So it's going to be negative here. Or let's say plus here. So I'm going to distribute the negative 2t to the power 5. And on the other side is going to be 12 t to the power 4. 12 t to the power 4.
Doesn't it say negative 6t squared above?
Which one? Which one? This one?
Yeah.
Negative. Yeah. Oh, yeah. This is 5. Okay. This is t squared. Let's keep going. Now, this is one term. So this one minus this one and this one with this one, because it's two vectors. So let's keep going on this one. So here is going to be t prime over t is going to be, we're going to write down this vector exactly the same, plus 36. And here, we're just going to simplify this one plus this one. So it's going to be 2t to the power 5 plus 72t minus 2t to the power 5. Okay. And the other one is going to be 0 plus 12t squared. That means this is canceled with this one. So t prime to the t is going to be, keep this one here, plus 36. And here is going to be a vector with 72t and 12t squared. Let's see, cubed here. When we distribute the cubed on this one, this is, oh yeah, check here is the wrong thing. When we distribute this one here, 3 with the 2 is going to be 5. The 3 with this one, this is t cubed. That means it's going to be 12t cubed. That means this one is a cubed. That means this one is a cubed. Now to make more sense, 72t. Okay. Now this is the prime. Now we just need to find the length for this one, which is easier to find the length. So I'm just gonna go ahead and write down n to the 2 is going to be t prime with respect to the 2 over the length over t prime with the 2, which is going to be, I'm gonna plug in 2 here. So this side is going to be 2 to the power 4 plus 36. And here is going to be 72 times 2, which is 144. And 12 times 8, 12 times 8 is going to be 96 over, you see, I'm plugging 2 here. On the bottom part is going to be the length for this one. I keep forgetting this, the exponents here. Negative 3 over 2. That means here is negative 3 over 2. The length for this one is going to be, here's the thing. Be careful here. we need to find the length for the prime. You're not gonna find the length for this part. This part is look like a number. Find the length for the vector. So when you find the length for the prime with respect to the t, this side is going to be, keep it exactly the same. Just plug in the t, -3/2, because you're going to find the length only for the vector, which is the square root of the first component square plus the second one square. So 144 squared plus 96 squared. That means this one cancel with this one. So the result is going to be 144 and 96 divided by, this one is going to be a really big number. So let's 144 squared plus 144 squared plus 96 squared is going to be a really big number. I'm going to take the square 29. 1 second. No, I did something wrong. I did put the sign. Because it's a plus. So 229,000 is going to be the square root of 29952. Then this one is going to be 144 and 96 divided by, let's check this one. 2, you see the number 2? If I divide it by 144, 208. That's good. So I'm going to say this is 144 times 208. So the final result is going to be 144 and 96 over 12 square root of 208. In this case, we can simplify it. 144 divided by 12 and square root. I think there's square root for 208, which is 13. Let's check 13 times 4. 12. We can simplify this one more. 48. 12 times 16 times 13. 16 times 13, 208. Yes. So here, I'm gonna say 208 is 144 times 16 times 13. That's mean it's going to be 12 times 4 and keep the 13 under the root. So in this case, it's 48, 144, and 96 over 48. And here is the square root of 13. 144 divided by 48 is going to be 3 over square root of 13. And this one, 96 divided by 48 is going to be 2. And here's square root of 13. So this is the principal normal vector. So I did all these steps, so which is good. We did refresh about if we have 2, how are we gonna do the 2 derivative with like 2 functions. You're gonna do the first one times the derivative for the second one, minus or plus. I put down the second one and the derivative for the first one. Did I add down here? Oh yeah, here. I put down the second one and the derivative for the first one is going to be the whole thing. Then you're gonna simplify it. 6, find the tangential and normal component of acceleration. So we have r of t, I think t equal to 3. Yes, you're gonna get exactly the same one. So example 6, which is R over T equal. I'm going to convert this one right away. So it's going to be T and 5 T negative 1. T and 5 T negative 1. So here is T and 5 T negative 1. And we have T equal 3. So we already know the velocity for this one with respect to the T is going to be equal the derivative for R of T, which is 1, and negative 5 T was negative 2. This is the velocity. Now, the acceleration with respect to the T is going to be double prime for the vector value function. So it's going to be 0, and here is going to be 10 T negative 3. Now, the acceleration with T to the tangent vector with respect to the T is going to be the velocity times the acceleration divided by the length of the velocity. That's mean with respect to the T is going to be, I'm just going to write down the vectors. The velocity is 1, negative 5, T is negative 2, dot product with the acceleration, which is 10, 0, and 10 T negative 3 over the length of the velocity is going to be square root of, here is the velocity 1 plus this one, so 1 squared plus negative 5 T negative 2 squared. You can keep it this one, find the dot product here. It's up to you. If you want to plug in the number, because they ask you to find with respect when T equal 3. So I cannot plug in the 3 here. Calculation with respect to the T3 equal. So it's going to be 1. And this is negative 5 over 9. Negative 5 over 9, because it's negative 5. And here is a 3, negative 2. And dot product with 0. And here is 10, 3, negative 3. And everything is divided by 1 plus negative 5, 3, negative 2, and everything squared. That's mean A with respect to the T, and here is a 3. It's going to be equal. I'm just going to simplify it. 1. This is negative 5 over 9. And dot product, this is 0. And this is 27. So 10 over 27. Everything is divided by 1. And this is a 25 over 9 squared. So this is 9 squared. This one, I'm just simplifying this part, which is negative 5 over 9. And everything squared, so it's going to be 25 over 81. That's mean here it's going to be the square root of 1 plus 25 over 81. Now do the dot product here and find this one. 80 with respect to 3 is going to be 1 times 0, plus this one times this one. So 1 times 0 is going to be 0, and plus negative 5/9 times 10/27. And everything is divided by square root of AU1. I'm just find the common denominator, 25 times AU1. It's going to be 2025.
That one already has the denominator of 81 though.
Which
you
one?
don't need
Oh yeah. Oh yeah, you're right. So 25, perfect. Over 81. That's mean this one is going to be equal 0, negative 50 over 9 times 27. It's going to be 243. And here is negative sign. I don't think so. I can simplify the top part. Here is going to be 81. Just add the 25, 106, square root of 106 over 81. Can we simplify it more? As a vector, 81 is 9. Yeah, because this one is a dot product. We don't have to write down here as a vector because it's a dot product. Zero plus. That's mean this one is going to be negative 50 over 243 times 106. Do we have square root of 106? 106. We can't, if you say 106, let's say divide by 4. You can't. 106. You can by 2, but it's going to be 53. So just keep it. And there's no square root for 2. For 2, yes. So it's going to be 9 over square root of 106. That's mean is going to be, we can simplify it. 9 with this one. 2, 4, 3 by 3 is going to be 81. By 9 by another 3 is going to be 27. You can simplify this one. This is a 27. This is 1, so it's going to be negative 50 over 27 square root of 106. Let's check 2, 4, 3. You can divide it by 9. By 9. 27, yes. There we go. We need to check this one. We didn't check the previous one. Oh, this is only A for the T. We need to find now the next part, which is I have 10 minutes. The next part is A with respect to the principal normal vector. Let's check this one, which is negative 50 divided by negative 50 divided by 27 square root of, I know it's not normal number, but that's what we got. The second part is, let's see, oh yeah. So don't scared if you got like this one. We just simplified. We're doing everything right. So just go ahead and plug in and you're gonna get the right answer. The same thing, but now with A with respect to the N, is going to be the other vector, which is you have to do the cross product. That means it's going to be the cross product, the length of the cross product over V. So we're going to do exactly the same steps, but now a cross product. So let's check this one. That's me. I need to do it here because I need to. I have the V and I have U. I have V equal, the velocity is 1, negative 5, T, negative 2. And I have A, the acceleration, which is 0, 10, T, negative 3. I have both these. So I'm just going to do the cross product. That's mean A with N is going to be the length of the cross product V cross A over the length of V. That means this one is going to be the length of the first vector is going to be here's the velocity 1, negative 5, T was negative 2, with the second vector, it's a cross product with 0 and 10, T with negative 3. And here is the length over the length of the vector V, which is 1, negative 5, T, negative 2. Then what we're going to do, we're just going to find the length and do the cross product. So let's do the cross product here, if you remember that, with IJK. IJK. There is no K here. So what I'm going to do, I'm just going to say K equals 0. You're going to get the same result. So I, here's 1, negative 5, and I'm going to do a 0 here. 1, wait a second, 1, 0, no, 1, negative 5, 0, yes, and 0, 10. Oh, I have to write down the T. 1, negative 5, T, negative 2, and 0. And here is 0 is going to be 10, T, negative 3, and 0. So this one is going to be equal. For the I, J is going to be 0. It's going to be 0. And the result is going to be a vector. So with the I is 0, with the J is going to be also 0. And with the K is going to be negative 5, 0 minus 10 T to the negative 3. Then the length for this one is going to be the square root of 0, 0. So it's going to be negative 10 T negative 3 squared, which is going to be square root of 100 T squared. So it's going to be negative 2 times, it's going to be just T negative 1. If you want to plug in right away here, T cubed. Careful, because with this one, it's supposed to be negative sign here. With the K, okay, with the K is going to be 0 minus 10. Yeah, that's right. So let's plug in. We need to find with respect to the T. So this one is going to be Let's check here. Can we, the length is -5. This is -10, t to the -3. And this is squared. I can make this one as easier if I just cancel the square with this one, because it's only one term. There's not a number with this one, so it's easier to cancel to make it just -10 t to the -3. Now it's easier to work on this one. For the bottom part, the length of this one, the length of, we can just find the length right away. We already find the length for this one before. The length of V, which is equal, if you go back to the previous, which is this one, because the length of the V, this part, this part, this part, which is equal 106 over AU1. So we already have this one. The length of V equal square root of 106 over 81, which is 9. Which is equal to square root of 106 over 9. So we already have this one. Now AN is going to be -10 t with -3 over square root of 106 divided by 9. That means AN with the 3 is going to be -10. 3 with -3 divided by 106 over 9. So it's going to be -10 over 27 times 9 over square root of 106. This one with this one. So it's going to be -10 over 3 square root of 106. 3 square root 1/6. Sorry. Let's go back here. So this one is going to be fraction -10 over 3 square root of 106. 106. Let's check this one. And if you see example 7, you're going to do exactly the same thing. Just let's give you a hint of example 8. We have something wrong here. I don't know where is the wrong thing. Let's check it. Yeah, so when you square, because you're going to square this one, and then you're going to take the square root. So this one is going to be positive, this one positive, this one positive, and the result is going to be positive. That's it. Example 7, you're going to do exactly the same thing, the same steps. So I'm going to leave this one for you. And there is no red line, so you're going to get exactly the same number and the same t. Example 8. R of t is a cosine. This is not w, the omega t I and a sine omega t j. So explain its value relative to the value of a with respect to the t. Which one is going to be the speed? If you find the length of the velocity with respect to the t. So let's check. It's just you're going to find the length of the velocity. That mean is going to be number 8. Sorry, number 8 or 9. Yes, number 8. R of t is going to be a cosine omega with the t I plus a sine omega t with the j. That's mean r over t is going to be a cosine omega t and a sine omega t. So the derivative, which is the velocity with respect to the t, is going to be a cosine and the derivative inside. So it's going to be negative a sine and the derivative here. So it's going to be omega sine omega t. And here is going to be a the omega cosine wt. So now what we're going to do, this is the derivative. The length for this one, that means the length for the velocity is going to be the square root of this one squared. So it's going to be a squared omega squared sine squared wt plus a squared w squared cosine squared wt. Let's factor out the at, aw, a omega. So a squared omega squared, and it's going to be here sine squared w or omega t. I keep saying w cosine squared omega t. This one is 1. So that means it's the square root of a squared omega squared, which is equal a omega. So if you look this one, that means the speed is decreasing, the speed constant, the speed is increasing. This is 1. So it's equal omega a omega. Just gonna say a omega. Can you hear my voice?
Yes.
Okay.
No.
So a omega a. I think we can write down a, but I have to choose the omega, which is this one. No, not this one. Oh, here. A omega. And now is the speed, because it's the same thing, so it's equal. That's mean. Yes, that's it. For example 9, I'm just gonna give you the steps because you're gonna get exactly the same thing. There's no red in it. So let's see, just write down the steps. This look like almost 11 steps, because we're just gonna add b equal t times n. That's what we need to find. So step 1, for example 9, what you're gonna find, you have the vector r of t, you're gonna find the prime, then you're gonna find the prime, write down this step with respect to the 1. Step 3, you're gonna find the length with respect to the 1. Step 4, you're gonna find the tangent vector, which is going to be the prime with respect to the 1. Let's do it to the 1 over the length of this one. Okay, step 5, we're gonna find the length of with respect to the t. Step 6, you're gonna find now t with respect to the t, which is going to be the length for r prime. R prime to the t over the length of r prime with respect to the t. The step 7, you're gonna find the derivative now. Step 8, find the derivative with respect to the 1. Step 9, yes, step 9, we need to find now the length of t with respect to the 1. On the step 10, you're gonna find n with 1, which is equal t prime over 1 over the length of t prime over 1. Then step 11, b, which is equal t, they're telling you t times n. T times n, they ask you to find b with 1, that means t with 1 times the normal principal unit vector. That means you already have this one. You already have this one, which is here. You're gonna find it here. And you already have this one here. You're just gonna multiply it, and that's it. So I'm just gonna give you the steps. Do step by step, because you have to practice on this one.